Good morning. So yesterday I had you complete this chart, and so I took the liberty of filling it in to do it myself. What I wanted you to see here is that we can tell the behavior of a function based on looking at just the equation. And we've talked a lot about how functions behave previously, and those things are not changing here. So the first thing you look for is the what we call the b value. Okay, and so if the b value is greater than 1, it's going to be growth. It's going to start off as growth, right? And if the b value is less than 1, it's going to start off as decay. Okay, and so we need to know the general shapes based on looking at the equation. So this function here is a growth function, right? It's a growth function, first function, I'm sorry. And so it started off as a growth function because 3/2 is greater than 1. And then we look at the value in the exponent, make sure that the x is not negative, and we look at what we call the a value, that number kind of out front of the b value, to see if it's negative, because that will reflect our graph. All right, but since this doesn't have it, our general shape looks like this. So we don't really need to know what it looks like, we just have to have an idea, right? And so then the next clue as to what's going to happen, if we didn't have anything added or subtracted, the end behavior to the left towards negative infinity would be 0. But because we have this -3, it takes our end behavior to -3. And because it's infinite growth, it's going to continue to go on forever as x approaches positive infinity. We're going to use that same logic when we look at the second function. We see that it is less than b, so we know it already started as decay. Right? And we're going to sketch that over there. We look at this value here, the x value is positive, and the 1 in front of our function is what, positive. And so we're going to stay decay. To figure out where it's going towards the end, again, we look at this -3, and as we get bigger and bigger and bigger, when we follow the shape, we see that it is going towards -3. As we look towards the left, it's going towards positive infinity because it came from something really high and then fell really quickly, going towards eventually trying to reach -3. Its intention is -3. The third example is where things change a little bit. We see that this is E is about 2.71, blah, blah, blah. So that would make this growth to begin with, but this negative makes it decay, right? So we would start like this, and then we think about what reflection a negative out front would give us. And so we see it here, right? If the negative is out front, we see it kind of dip down to decay. And so there we have what our graph looks like. The +2 is almost going to be the roof of this function, right? So as we approach negative infinity, we're going to go to 2, and then we're going to keep falling and falling and falling as decay does. For the final example from an equation, we know that that 1/2 is less than 1. So we expect for it to be decay. So we're going to start out with decay. But then what happens is we have this negative again in front. And so what that should do is flip it up. And so this is always a better graph, but we will now see that it's going to flip over that axis. So like if you imagine that it looked like this, the negative flipped it down. And so now, while we have growth, right? I'm trying to show the graph again. While we have growth, now we expect it to go like this and to kind of cap out again at 2. Okay, so now when you think about example 1 and you go through the chart, there are 3 different options we could get from this graph. The first thing we could get is that it's going towards negative infinity, right? And so since it's end behavior, we can just talk about it in terms of negative infinity. I think you guys understand that if it's an infinite limit that it doesn't exist because it's going to keep on going. The second thing we could have gotten is positive infinity. And then the final would be if we have some b value, right? And that's where we see these 2s and -3s, or it would be 0. And this would be our horizontal asymptote. And so what you're looking for in these examples is to see if there's a horizontal asymptote, because that's going to be the end behavior of one side of our graph. If there is no horizontal asymptote in terms of being added or subtracted, then it's going to be going towards 0. All right, and so in terms of having what makes something growth and what makes something decay, I'm going to look to talk about this section here. If it is growth, we could have growth if we have our B value less than 1 and 1 reflection. We also could have growth if we have our B greater than 1 and we have 0 or 2 reflections. Because if you keep reflecting it, or you reflect it twice, if there's 2 negatives, like the negative with the X term N out front, then it goes back to being growth. And then the second one would be decay. And we would see decay if 0 is less than B is less than 1. And we would have no reflections, or we would have 2. Again, switching back and forth. But if the B value is greater than 1, we're going to have 1 reflection in order to have it change to decay. All right, so looking at A and B here, I don't really want to sketch these. I want to just kind of talk about what they would be doing and what they look like. We are looking at the limit as it goes to negative infinity. If we're looking at the limit as it goes to negative infinity, the first thing we need to look at is, do we have, based on our B value, growth or decay? And so based on our B value, we have decay. But we have a value out in front of our X that now makes it growth, because it is reflected across, this horizontal asymptote. All right, so if it was decay, it would look like this. And then a horizontal switch will change it to this. So now when we look at the limit as X approaches negative infinity of this function, we know, just based on just kind of sketching these graphs, that negative infinity is where this thing is going. Take a look at one more example, and then I'm going to leave the other 4 for you guys to do today. Here we're going to start out the same way. We're going to look at the B value. The B value is E, which makes it growth, right? B is greater than 1, so we start out with growth. And then we look for reflections. So now we see that we have a negative X term, which is going to switch this to decay, right? So that negative X makes this decay now. So again, if it started out right, it would look like this, growth. But now we're going to flip across the y-axis, because again, these translations happen, they change the X, right? Now we have decay. And so now if we're looking to evaluate the limit as X approaches negative infinity of E to the negative X plus 1 minus 3, we would anticipate that it's going to go to positive infinity, therefore DNE. And by the way, if we had to evaluate the other limit, let's say it asked for as X approaches positive infinity of this function, we know that it's going to go towards negative 3, that horizontal asymptote, right? And so that's what we know just based on the equation, right? That this is equal to y equals negative 3. And if I went back here, we would have y equals 2. Okay, so your assignment for today is to complete problem C, D, E, and F in the document. Make sure you like and comment on the video, and reach out to me if you need any help. Have a good day.